Good afternoon and welcome. Thank you for joining us for our belated 10th anniversary Passivhaus Awards ceremony. The best things come to those that may wait, and I can assure you that this afternoon we will not disappoint you. It'll be more exciting than last night's football and the edited highlights of Matt Hancock's office CCTV footage, I promise. As part of London's Climate Action Week 2021, and in the midst of over 75% of district, county, unitary and metropolitan council having declared a climate emergency, it is timely that today we showcase the very best passive house projects from across the UK, the tried and tested way of delivering the buildings we need to tackle the climate emergency. I'm your host today, along with the most talented and renowned sustainable celebrity, Charlie Luxton. When I'm not helping the Passivhaus Trust as a trustee, I can be found developing passive house projects in my home city of Exeter. Behind the scenes today, we have a finely tuned team of helpers who are all posed to make this virtual event seamless and enjoyable. In case you do not catch sight of them, I express thanks to the Passivhaus Trust staff team and the volunteers who've made today's possible. For those of you unaware of the Passivhaus Trust and what they do, check out their website and you will see a wealth of resources and materials, plus information about joining this fabulous family network. Now, before I explain the format for this afternoon's awards, let's just indulge ourselves on some of the key achievements of the last 10 years or so of the Passive House in the UK. From the UK's first Passive House certified home in Machynlleth, and the second, I hasten to add, in Exeter in the same year, to the formation of the Passivhaus Trust in 2010. Over the last decade, we've seen the delivery of over 1,000 passive house projects, including one very special project that secured the Sterling Prize in 2019, the wonderful Goldsmith Street development on behalf of Norwich City Council. That's quite telling for the year that the UK declared its climate emergency. Our official 10th anniversary was last year, but we've taken the liberty of rolling that birthday into this year and this special awards ceremony. The interest in and uptake in passive house across the UK continues to grow. That's most encouraging, especially as we're facing an inevitable climate disaster. We now have over 1,400 certified passive house buildings and more than 6,000 under development. And across the UK, we are seeing passive house projects grow in scale and complexity. Residential projects have gone from being single to multi-residential, new build and retrofit. We're seeing more large scale and high-rise projects, and passive houses also began to feature in master plans in Exeter, York, Edinburgh and Glasgow. Beyond residential, we are seeing a growing number of non-domestic passive house buildings, both new build and retrofit, from village halls to schools, university facilities and accommodation, offices, museums, leisure facilities and more. All of this in less than a decade. Our programme this afternoon showcases the very best of the latest passive house projects from across the UK. You'll see 6 finalists across 2 categories, small projects and large projects, and each finalist will share a video of their project and give a short presentation on their entries. After the presentations, you'll have the chance to ask questions via the Zoom chat facility. Now, these awards are very much peer accredited by the UK Passive House family. Our selection process has been 2-stage. A long list of entries were shortlisted by a panel of recognised and respected professionals, made up of John Bootland, Nick Grant, Hattie Hartman, Eugenie Patel and Lynn Sullivan. Our thanks and gratitude to each of them for their contributions. The second stage was made up of 500 or so of the Passive House members who have voted on their preferences. So these awards reflect the opinions of many. Now, we do have a final category, which is the People's Choice, and this is where the wider public get to determine the outcome by voting via a live poll at the appropriate time. So what do I need your help with this afternoon? Well, firstly, I must inform you that this event will be recorded, so cameras and mics will be switched off, all bar presenters. Secondly, we are on a live platform, So you can interact with each other and with the presenters via the chat or Q&A icons at the base of your screens. By all means, post your comments and share links in the chat and use the Q&A for questions which you wish to see posed to each of the project presenters. It may well be that your questions sway the voting. Finally, make sure you have your champagne on ice or your beer at hand, or whatever your preferred tipple is, ready for when we toast each winner after each category. Now let's get these awards started, and who better to get us in the mood than television's multi-talented architect and sustainable champion, Charlie Luxton.
Hello, hello, hello. I hope you can hear me. Wonderful to be invited to talk at these awards. So why are we here? Why do these awards matter? Well, I'm clearly speaking to a Zoom room of self-selected individuals who understand the issues around sustainability, but I always think it's worth just revisiting this question, because what we are doing to our planet is collective madness. It is a massive failure of our sort of wiring, our algorithms, and it makes us blind to our behavior. So look, it's going to start bad, but I assure you it will get a bit more positive. Between 2011 and 2020, it was the hottest decade on record. 6 of the warmest years have been since 2015. 2020 was tied as the warmest at 1.2 degrees above pre-industrial levels. We've seen a 60% drop in the number of wild animals in my lifetime. And James Lovelock, the godfather of climate change and Gaia, thinks that a post-climate change world will support about 1 billion people living in the north. The journey from 8 billion to less than 1 billion could be bloody and chaotic. To avoid this, we have around 10 years to radically change our civilization, our global economy, and keep below 1.5 degrees change in temperature. It is all stunningly bleak, but for the first time, I am really beginning to believe that we can do this. I think we will be able to live on an Earth that's in reasonable numbers. I mean, it will be a different planet to the one that you and I were born on, but still recognizable. So why positive? Well, I think it's partly timing. The conditions feel right. The real threat of climate change is now absolutely clear and present. And it also is a matter of the messengers, the kinds of people telling us how we need to change and what we need to do, the kind of stories that are being told, because this is human nature. We need stories, and we need people to create and to tell them to us, because culture feeds off stories. They're about who we are and who we want to be and what we want to achieve. So this is why it's crucial that we have a story to believe in, and when we do, we can achieve amazing things. Now, the story for much of human history has been about getting to a place we are warm, fed, healthy, we've got friends, there's fairness and there's opportunity. And this has been a utopia for which we have been prepared to sacrifice so much for so many years, decades, generations, millennia. And for many of us in the West and increasingly across the globe, we are getting there. I mean, the facts are we are healthier, better off, living longer and in ways that we could never have imagined. But this utopia is a kind of poisoned chalice. There is also massive increase in loneliness and unhappiness, a crash in fairness. And, you know, we've never actually had it so good, but it's a sort of an illusion. It's that wonderful moment of weightlessness when you're kind of on a skiing trip or going on a downhill mountain bike and you see a jump and you get a bit overexcited and you hit the jump and you're in the middle of the air and everything's going brilliantly. It's completely weightless. And then gravity kicks in. And if you're anything like me, pain usually follows quite quickly. So we are been following a story that is in effect an illusion. So we need a new destination and a new story. We need to develop and demonstrate solutions and alternatives that show what a transition to a zero carbon economy looks like. Because right now, we don't know. And as a recent report from the Climate Change Committee points out, the government current plans fall woefully short of their idea of carbon neutrality by 2050. So clearly Boris has no idea what a sustainable future looks like either. Now, For me, a reason we need to see and celebrate what sustainability looks like in all manner of ways, including the Passivhaus Awards, is because for many, sustainability is inextricably associated with no and can't. You can't fly, you can't drive a 4x4, you can't eat blueberries in November, no beef burgers, and on it goes. Now, for me, this is wrong, and not just because I do like the occasional pasture-fed beef burger, but because fundamentally, when you learn to drive, the one thing you learn if you're trying to drive between two posts is not to stare at the post. Always stare at the gap. And up till now, so much of what we discuss around climate change has been totally focused on the negative impacts of climate change, the no, can't, shan't, and not actually on, well, what does this post change in our economy actually look like? What are the opportunities as we rewire? Now, this is especially important when talking to all of you, because buildings emit between 40 and 50% of all CO2 in advanced economies. So what we do, the stories we create by our actions, matter almost more than anyone else. And to reach our goals of carbon neutrality in this country, certainly we need buildings to be carbon negative in occupation and construction well before 2050. And now we need to refurbish, which in a fit is super important, around 25 million homes. And unfortunately, we add to that problem at a rate of about 200 to 250,000 homes a year, because the vast majority of new houses we build today are perfect for complete retrofit the day before anyone moves in. We also have the performance gap at about 100%. So when we design a new building, it will use double the energy predicted by its SAP or EPC. For offices, that's 200%. For institution buildings like schools, that's around 300%. Because we have an industry solely focused, for many, on ticking boxes, shuffling papers to certify things without doing almost anything. No one goes back to see how the final buildings perform. They move on to the next one, learning little with little analysis. So it's a huge challenge, but I am positive because of what you are designing and building, the amazing homes, schools and offices, the wide variety of structures that we're here to celebrate today. Passivhaus tackles so many of the issues that face us, creating healthy, low energy buildings that benefit both the environment, so the planet with a big E, but also with a little e, our immediate surroundings, internal air quality, creating healthier homes. And this makes a huge amount of sense to me, because one of the biggest barriers for uptaking in wider building is very short-term accountancy and short-term thinking. And I've always found it really odd that we haven't been building low energy buildings for a long time, because I saw a talk back in 1997 and I had a real epiphany, and it's sort of what led me into architecture and running an architecture practice. Just to point out, I'm not a qualified architect. I have a master's in architecture. I didn't do the last bit, but the talk was by an architect, and he built a bank. He built a bank for a corporate bank, and they wanted to bring 3 different buildings together to make their staff come together and to be more efficient. But they also wanted to make it as deeply sustainable as they could, because they felt that obviously creating a better work environment would make their staff more efficient. So they put in natural daylighting, high levels of insulation, green roofs, everything was absolutely cutting edge today, but in 1997 seemed extraordinary. Now, it cost more money. It cost about 10% more money to construct. But what was fascinating by this, and why I've really struggled to understand about the low uptake in sustainability and low energy buildings, was because when they did some occupancy analysis of the building, they realized that they had about a 10% improvement in staff productivity. So 10% increase in cost, 10% increase in staff productivity. And you think, oh, that seems like a reasonable investment, until you look at a life cycle analysis for an office building. And if you do that, building it, running it, maintaining it costs about 10% of the overall life cycle cost. Wages are 90%. So arguably, they spent about 1% outlay on the 10% increase in the improvement on the building to get effectively 1,000 times return on investment. So you think that when you think about the short-termism that riddles our society and creates waste and misery, there's so many out there. There's another fantastic one which talks about the Welsh economy, and they believe that bad housing costs about £1 billion a year to the Welsh economy because of both physical and mental impacts, absenteeism, degradation, additional heating. Because damp, poorly insulated and ventilated buildings make people sick. And this is clearly bad in any country. But it is both bad and stupid in a country that quite rightly treats its people through the NHS and supports people who can't work through benefits. It is a massive drag on our economy. It's estimated that every £1 spent on improving air quality returns £4 before you consider the wider benefits. And actually later this year, Passivhaus Trust are working on a report around the impacts of healthier buildings. You should get that towards the end of the summer. We need to start thinking about the wider defrayed cost on society and the planet before we do anything, before we build, travel, move, make, grow. And as soon as we do that, there's many positive feedback loops that occur. Better ways of doing and building, like passive. You've seen massive transformations in the likes of the energy generation grid. The UK grid has decarbonised by about something like 50% in 5 years. And the automotive industry, which has gone from 1% of EV sales in 2015 to the estimated 20% 2021 to 50% by 2025. I mean, these are seismic shifts in big industry, and this needs to happen in our sector. And we need leadership from the government to do that. We need them to pull all the levels of taxation, grant, planning, and building control to shift the playing field, to encourage and support fabric-first building techniques, not just quick technical fixes of heat pumps and solar panels. We need lenders, local councils and housing providers to focus not just on affordable rents or mortgages, but affordable, healthy living. So the additional cost and complexity of sustainable homes can be financed actually in construction and not defrayed onto wider fossil fuel use during the life of the building. And we need to engage local people in new housing. So it is not just about profit. And we need to bring, my final sort of ranty point, we need to bring nobility back to construction. We need highly skilled people who don't see going into building as some kind of last resort. And we need to fund that properly and not just support and finance the large house builders with the right to buy. Now, I wouldn't necessarily hold your breath for this government to act on this, but even if they continue to fail in leadership, it strikes me that the fundamental economics and history are on our side. You know, we look up and understand the real impacts of what we're building and deal with the challenge. We hopefully can deal with the challenges of climate change and create a better, fairer society. So Passivhaus techniques and these awards have a role to play in that. There's a long way to go, but there is a spark of hope that we need to carefully fan and nurture. So whilst I'd really love to congratulate all of those who are nominated today, and obviously the winners, that I have no idea who they are either, I also want to thank all of you for taking the time for attending this award and to keep going, being interested, creating the buildings, the examples, the stories that we need to lead the way. Thank you very much for listening and good luck with the awards.
Thanks, Charlie. A very compelling argument for the societal, planetary and financial benefits of building better and building more sustainability. So let's kick off. I'd like to first introduce you to Ian Rigglesford of the Ecology Building Society. They have generously supported and sponsored this small projects award category. Over to you, Ian.
So I just wanted to say a few words about ecology and supporting the small projects category of this year's awards. So many of you will know that Ecology, we've been building a better, greener society for 40 years. So this year we're celebrating our 40th anniversary at Ecology by using money for positive environmental and social impact. And many of you will also know that as a patron member of the Passivhaus Trust, we've been a long-standing close partner and supporter of the Passive Trust right away from the very beginning of the trust development nearly 11 years ago. And our unique sea change mortgage pricing incentivizes energy efficiency. And we put Passivhaus right at the center of that. So that completed accredited Passivhaus projects achieve our greatest discounts because we think that Passivhaus is where it's at in terms of energy efficiency and tackling climate change. And that's why we're especially delighted yet again to be supporting the small projects category of the Passivhaus Trust Awards, recognising the very best of Passivhaus in the UK at the small projects end of things. Now, I understand that this year the standard of entries has been higher than ever, which shows that Passivhaus really is pushing the envelope in terms of sustainable designs. And I'm really looking forward to hearing more from the 3 finalists. Thank you, Emma.
Thanks, Ian. And thanks very much to the Ecology Building Society. We are very, very grateful for the continued support and encouragement that you give to the Passivhaus standard in the UK. And thank you for joining us this afternoon. So all our finalists have been allocated a 2-minute video this afternoon, and each will be then given a 6-minute presentation opportunity. After that, there'll be an opportunity for a short question and answers based on the questions that you put in our Q&A icon at the bottom of your screens. Now, first up this afternoon in the small projects category is Mark Sedal of his project Larch Corner. Now, Mark is very much a UK Passivhaus rock star, having been an early pioneer of the Passivhaus standard in the UK. He has oodles of experience and expertise and is very generous in sharing this and helping others. Mark is the Director of Architecture and Research at LEAP, the Lovingly Engineered Architectural Practice. And today, Mark is showcasing his Timber Triumph, Larch Corner, a new detached Passivhaus home in rural Warwickshire.
You'd bought a plot of land. We obviously had planning permission for a bungalow on the site, but it was a much more complex design than we've ended up with. We had to rationalise it quite significantly.
Well, I wanted a low energy build, so that's what led me towards looking at Passivhaus. And I'd looked at various methods of building, like straw bale, but I've always had the interest in building with timber.
So of course we talked about different ways of building the house at different points. We talked about timber frame, but we always returned back to CLT because you wanted that internal finish and the quality, the quality that would give to the house.
It's lovely. It gives me a very nice aesthetic internally, and I've probably ended up with timber everywhere. There's nothing other than timber above ground floor. Everything
in the walls as well, even the wood fibre insulation,
yep.
And then the larch cladding on the inside. The windows are timber, yeah. And of course along that way we also achieved some very good air tightness. The air leakage would fit on the penny coin, which is 244 times more airtight than building regulations would require. Yeah. And as far as we've been able to gather, it's about the 3rd most airtight house in the world.
Rather ridiculous and somewhat unexpected, because I did all the air tightness taping and it's just worked out very well. So I've been through a winter. The heating went off early March and I haven't touched it since. It's very nice, very comfortable, and the air's great. It's all very even temperature around the house, which is one thing that you really notice with the mechanical ventilation, and it's really working well.
So Larch Corner is a timber lover's paradise situated in the Cotswolds area of outstanding natural beauty. The site itself is enhances biodiversity with grasses and wildflower meadows, edible landscape, native tree planting, discrete permeable parking, and a cedar roof, which also attenuates rainwater runoff. From the cladding to the structure, from the insulation to even the light fittings, upfront carbon emissions have been considered. The windows frame the views, and there are 21,000 screws that fit into a design for disassembly strategy. The family home has wheelchair access, and space planning means there's privacy and a wealth of storage. Up on the right-hand side, you'll see the sedum roof, which also supports part of the photovoltaic array, and we've got a sawtooth profile that addresses the curvilinear road at the eastern side of the house, with south-facing windows making the most of the solar gains and the views available. The gargoyles on the roof gently throw the rainwater down onto the landscaping down below, and the deep window reveals provide shading in the summer. The window seats that feature in a number of views allow you to take a pew and accept a view and even read a book. And the waste from the house that arose during the construction process was minimized as much as possible, and CLT, the cross-laminated timber, was used as offcuts to make the dining table, for instance. The ceiling heights vary throughout the house to accentuate different spaces, and the hallway includes space for a wheelchair and for buggies, so that Mick, an active grandparent, can accommodate his family. The storage wall has playful LED lighting, and the office has a fold-down bed, so Mick can give over the rest of the house to visiting family, and he's still got somewhere to retreat to. In terms of energy performance, of course, we tick all the passive house boxes, and most notably is the fact that the air tightness is would fit on the square on a 1 penny coin. 244 times better than building regulations, 16 times better than the passive house standards would require. Needless to say, there was plenty of celebrating on the days when we got that result. In terms of the actual measured in-use performance, compared to 2,000 passive house dwellings that in a peer-reviewed paper that I helped to contribute towards, we can establish that Larch Corner is using 15 kilowatt hours per metre square per annum on average, and that's within measurement error. And if we allow for a bit of drying out, then it firmly falls within expected boundaries. In terms of summer comfort, we avoided overheating risks primarily by designing out excessive areas of glazing and designing for good standards of natural daylight. The certification exceedance of 25 degrees Celsius was expected to be around about 9%, but that was because of my undue concerns about insects inhibiting the opening of windows. In practice, what we've found is that the area weighted exceedance is 5.5%, which actually accords very closely with the Passive House Trust best practice processes there, which would suggest that the expectation from PHPP would be 4.5%. So we're in the right sort of territories in terms of correlations there. In terms of actual energy use in practice, what we can see is that the photovoltaic array has displaced 1.8 tonnes of carbon emissions, but the house is connected to the grid, so the winter gap emissions were 0.7 tonnes. If we look at the photovoltaic energy use, then we can see that the house used around about 40% of the electrical energy generated by the PV array, and 60% was exported to the grid. In terms of indoor air quality, if we use relative humidity as a proxy, then we can see that the house remains within the ideal zone for around about 85% of the year, trimming down to somewhere between 30 and 40% for a limited period, because the house is occupied by one person, and therefore there isn't the same amount of moisture that's being generated than we may otherwise expect. As you'd expect with a passive house, because the domestic hot water loads are greater than the space heating demand, the air source heat pump was optimized for domestic hot water use. However, low occupancy and low domestic hot water demand, as well as some rodent damage to external pipework, means that the COP of the air source heat pump, as measured, is 2.3. Upfront carbon emissions were estimated, and what we found was that the photovoltaic array accounted for 23% of the total emissions, similar to the amount of emissions arising from the concrete floor slab. In total, 69 tonnes of emissions arose from that design and construction process. Of course, there's carbon that's within the timber structure itself. And if we look at the CLT, the insulation, the cladding and the flooring, then we found, strangely enough, that we also sequestered 69 tonnes of carbon. So we could call this net zero in some contexts, but I think that would be a bit of a foolish game to try and argue. That's not how the ISO standards work. So more contextual thinking would be to recognise that the house achieves a 38% reduction in upfront carbon emissions compared to a masonry built passive house with external wall insulation. Next time on a different site without the same planning constraints, we'd build to 2 stories, and we would also use engineered I-beams to improve resource efficiency even further. We'd also not necessarily invent the carbon calculation tool from scratch. We'd use pH ribbon because that neatly plugs into PHPP. The house features the UK's first installation of blown wood fibre insulation. We used finished duct cleanliness standards to ensure good standards of duct cleanliness, because they're not picked up by passive house or building regulations. The ACB water standards were used, and we also included a domestic sprinkler system so that we could use low toxicity paints on the inside. Lessons learned: world-class air tightness standards can be achieved quite easily. surprisingly, we did this by accident. We weren't setting out to achieve that. We wanted to achieve a passive house. Obtaining environmental performance declarations is time consuming, another reason to use pH ribbon. Renewables contribute significantly to upfront carbon emissions, and getting in-use data can be quite tricky. So closing out, in terms of mix, closing comment here, I love Larch Corner. It gives me a wonderfully quiet, calm, comfortable home that's extremely economical to run. I really appreciate the superb daylight. So that's Mick's concluding comment there. So all it leaves me to say is that this is our contribution to the Oscars of building performance. And after the event, if you'd like to get the full documentary, go to passivhausesecrets.co.uk. So thank you very much, and back to you, Emma.
Right. Well, thank you, Mark. Fantastic. Brilliant project. Now we've got a couple of questions that have come in. First one's from Mike. He asks, were there any problems in obtaining planning approval given the flat roof and its context with the neighbouring properties that have got more typical roofs?
No, in fact, the flat roof was driven by the neighbouring properties because of the neighbouring property wanted a view out of over the top of the house. So the form of the house was limited to 1 story, so we hadn't got an opportunity to do anything different.
Okay, thanks for that. We've also got a question in from Tony. He's asked, if the sprinkler system is activated, what damage would this cause to the internal areas, and how could this be replaced?
Well, it's obviously there as a kind of a fire suppression issue. So therefore, the health and safety and well-being of people come first. It would only work on a localized basis, and it's a misting system rather than a kind of, so we're not expecting torrents of water necessarily. So yeah, it's working very well in that respect, and it worked out more cost effective than using fire retardants on the wall finishes.
Great, thank you. And then we've got a question from George. Why is it tricky to obtain in-use consumption data?
Just getting the monitoring done, finding all that information from Mick painstakingly went and read his meter. We didn't have digital relays and things like that that were readily accessible to give me that kind of information at the time.
Okay, and we've got another question from Priyanka. Did you use any recycled materials for the finishes structure of the building?
Well, the structure is timber, so it's not recycled as such. It's what we did use was the wood fibre insulation is used from is processed from thinnings, from kind of waste byproducts from processing timber. So therefore, we've made a net reduction in kind of avoiding that kind of waste.
Great, thank you, Mark. A fabulous project, and best of luck.
Thank you very much.
Our second shortlisted project this afternoon is New Forest Enefit, presented by Ruth Butler. Now, Ruth is no stranger to Passive House, having self-built her own Passive House home in Hampshire. Ruth is an architect and a registered RIBA client advisor who specialises in contemporary low-carbon refurbishments as well as new build. New Forest Enefit is a renovation transformation of a 1930s house into a wonderfully comfortable, naturally daylit and terrifically energy efficient home in an enviable location.
We first got in touch with you a few years back to ask about improving the energy efficiency of this property.
I'd heard of Passive House, but I thought you had to build a Passive House. I thought it was just a new build. And then doing some research, I found out that you could retrofit old houses.
Yeah, it's got fantastic bones and relatively straightforward as well, because of course it was a rendered building to start with. I think we did the right thing in the fact that we agreed that we would, instead of extending, we would reorganise the interior and we would make the best use of the existing building that we currently have. And then we got a team together.
Which is where we stepped in. One of the most interesting things for us right from the start was trying to change the mindset of the guys doing the individual work, and also changing the mindset with kind of the sequencing.
I remember you saying that you were going to target new build air tightness, even though it's a deep retrofit. And you achieved it.
We kind of said to Ruth right at the start, what do we do if we don't get it? And Ruth kind of said, no, we will get it. Having now done it, you do it right, you do it methodically, you follow the processes, and you will reap the rewards.
Living in a passive house means that the temperature is very constant. It doesn't seem to vary very much.
The house cools down slowly, and when the sun's out it heats up quite quickly. There are no drafts.
And it's quiet.
Yeah.
And where we live is quite windy, so we've noticed that.
Having measured embodied carbon on new build passive houses, even those that have got timber frames and timber cladding, your benefit here is half the embodied carbon of a new build.
Thank you, Emma, for the introduction, and I'm delighted this project has been shortlisted for this award. It's been a fantastic project for us, deep retrofitting this existing building to create an ultra low energy, low carbon home for my clients, Dave and Julie. This original 1930s home is typical of much of our housing stock in low density neighbourhoods across our country, with cavity wall construction and a pitched roof. I'm delighted it was certified Passive House Enefit in 2020. Dave and Julie, they didn't want to move from their coastal location and from this view at the end of their road in the New Forest, but they did want a comfortable, low energy home. So we worked quite hard within the constraints of the existing site to make sure that we could achieve their ambitions. The design philosophy was to create a contemporary open plan home that was super comfortable and low energy. And as keen design gardeners also had to have great indoor-outdoor flow. We rationalised the interior layout, we knocked down walls, and we created a new garden design and terrace. We introduced new high-performing bifolding doors to increase the amount of south-facing glazing, to optimise winter free heating, and to bring views of the outdoors in. A generous kitchen sits at the heart of the house. It was important to create robust details for the main thermal elements and to reduce thermal bridging at existing building junctions. The walls were wrapped with external wall insulation, the wall cavities were filled, and the loft and floor insulation was added. The air tightness solution was a combination of parged walls and air tightness membranes for the floor and the ceiling. We paid careful attention to the junctions of the floor joists, the windows, and a new floating floor for the ground. An air tightness of 0.5 air changes an hour was achieved, bettering the new build standard. The building services strategy was to keep it simple, reduce the amount of kit, minimise distribution of services, and adopt an all-electric solution ahead of the decarbonisation of the grid. One electric radiator is all that's needed to heat this house. These are the floor plans for the building. One of the more complex areas was thermally separating the integrated garage and providing a new utility and plant room space. We needed to find a door that was both Passive House certified and half an hour fire rated to go between the house and the garage, and discovered there was only one product in the UK available to do this. Aesthetically, the interior remodelling brings good daylight into the heart of the house with a new open tread oak staircase, larger doors and big windows. Natural materials were chosen throughout, including cork and timber floors. To the south, a new simplified elevation removes an old dormer window at first floor level to promote better headspace in the bedrooms and give roof space for the solar panels. On the ground floor, the existing conservatory was demolished so that living spaces could connect directly to the garden. external insulated render, beg your pardon, provides a clean contemporary line in keeping with the house's 1930s origins and the existing streetscape. And a warm, draft-free interior allows Dave and Julie to live in the whole house, no longer needing to close off rooms to keep warm. The client has been monitoring energy for over 2 years now, and the graph shows the monthly kilowatt hours for a 1-year period. The retrofitted house whole energy use is the bottom yellow line, and the pre-retrofit energy use is the top blue line. And the house now uses 75% less energy than it did before. The combination of winter solar gains and 1 radiator is enough to keep the house fantastically comfortable and draft-free in winter. And this is much valued by Dave and Julie, who's previously struggled to keep warm, wearing jumpers and slippers for most of the year. The summer shading is achieved with deciduous planted arbour, connecting the house to the garden and giving a shady spot to sit. And while the existing masonry walls provide good thermal mass and coolth to the interior. One of the key challenges for the project was following the insulation and air tightness line through a myriad of existing construction details. Particularly difficult was the ceiling skillings at first floor level and also the internal garage. We used PHPP to test the options and make sure that we were in compliance at all times. So in terms of lessons learned, the 3 key ones were that the pre-construction workshop that we held before we started on site was pretty essential for team building. The M&E installation could have benefited from closer supervision on site. We had a couple of things we needed to keep an eye on. And Air Tightness Champion was probably the most important person on site. Dave and Julie are delighted with their new home. It secures their retirement future in this much loved part of the country. And for me, measuring whole life carbon has been an important benefit. This deep retrofit is less than half the embodied carbon of a timber frame new build. This is a ready to deliver example of the performance and comfort that could be achieved across the existing UK building stock by deep retrofitting to Passivhaus Enefit standard, meeting the government's targets to achieve net carbon zero by 2050. And my sincere thanks go to everybody that made this project possible.
Thanks, Ruth. A really inspirational project, and it's really encouraging to see an Enefit project reach the shortlist. And I know it's an immense challenge taking on an existing building, but it looks as if you've achieved some amazing results. So congratulations. So we've got some questions that I've just got a couple of minutes to pass over to you. I see that on your slides you covered off the cost question that we had in the Q&A. I just got a couple of questions. Firstly, was the garage included within the envelope of the sort of Passivhaus envelope of this building?
So half and half is the answer to that question. We moved the line and we increased the treated floor area by the value of the plant room and the utility room. So we did leave enough space for a car.
Great. Also got another question from Priyanka. Thank you, Priyanka, for putting your questions in. How did you prevent overheating of the thermal mass?
So I think the existing masonry walls are really helpful to start with, and we put external shading over the big south-facing bifolding doors, which is based on some deciduous planting. So in the winter time, the leaves are not there and the sun will get through, and in the summertime, the leaves will be there and it will provide shading to the interior.
Okay. And we've got also a question from Elizabeth. She's asking, is the main entrance part of the thermal envelope as well?
Yes, it is. Yep.
Right. And just a final question really from myself. How did you deal with insulating the ground floor? Because that's often a problem or a challenge, I would say, in Enefit projects.
Yeah, we were lucky in this instance in the fact that the 1930s floor to ceiling heights were generous enough to allow us to overlay some insulation on top of the existing floor, which was a mix of concrete and raised floors.
Great. Thanks, Ruth. Thanks, Ruth. Very exciting project, and best of luck for the awards section. Okay, so our final shortlisted project for the Smalls project category is Devon Passivhaus. This is being presented by its owner and the client, Nigel Dutt. Now, Nigel is certainly a brave client, having taken on the local planning authority to secure the consent in the first place, and that's, I believe, is despite a refusal, a recommendation for refusal. And he's also working with the Passivhaus standard for the first time. The architect and the contractor are all first timers to Passivhaus, so he's reached an incredible outcome in delivering a certified Passivhaus project and being shortlisted for Passivhaus Award. So congratulations, Nigel, on that. Now, Devon Passivhaus is a contemporary, sleek self-build. It's contained within the confines of a historic walled garden. And Nigel's film now is going to give us a bit of insight into that particular project.
Well, we spotted this plot that was at the time really overgrown, surrounded by tall leylandii.
We couldn't find a house to buy. We knew we wanted to leave our old house, and so we thought building was the perfect option, and to get one we wanted.
And the architects we like best are all architects doing highly contemporary work.
They'd seen some of our work, and they had their eye on a site a little bit away from their house. And it was interesting because the site didn't have planning permission, and so it was quite a challenge.
The planners were really not keen. They say you have to go through the paragraph 79 route, and I think if we hadn't been so stubborn, we would have given up long ago.
Well, with paragraph 79, you really have to start with the site and what that is telling you. We were lucky there because there was a lot of drivers on the site.
This area was part of the walled garden of the big country house that's over the hill. So the old wall was such a dominant feature that the house somehow had to speak to the wall, if you like.
Because the wall is so prominent, we didn't want something showy, we wanted something quite low in the landscape. So this idea of putting a new wall, a sort of facade fronting the house, meant that the building behind could be whatever it needed to be. And we achieved planning, and it wasn't as a Passivhaus, it was just as a really sustainable building. And it turned out through our processes that we felt using Passivhaus was the best way to ensure it was going to meet those standards.
The total construction time was about 14 months. The first phase of it was to build the concrete slab and the concrete box which forms the basement. And once all that was done, Tribus, who did the full wall SIPS construction, built the house.
It's so comfortable. You're wearing t-shirts in winter.
It costs in net nothing to heat this house.
So good afternoon. This is one of those now for something completely different moments, as Emma said, because I'm the client and not the architect. Or at least I'm one half of the client and not the architect. So our project's a new build in Devon, designed by McLean Quinlan. It's around 360 square metres TFA, single-storey house with a partial living basement under about a third of it. We bought the plot in late 14, started building in late 17, and moved in at the turn of 1819. So we've been in here for a couple of years now. The first challenge was the site itself, which, as you can see, is dominated by this tall red brick wall of the old kitchen garden. But the big challenge was that local planning declared it to be an isolated house in open countryside. So we had to go the paragraph 55, now 79 route of the National Planning Policy Framework. And this in turn meant that an independent design review panel had to determine that it was truly outstanding architecture, raising the standards of design in rural areas. And then, of course, we had our own client brief, which included Passivhaus and energy goals, which were not necessarily complementary to the Para 55 requirements. But we succeeded in getting that. And here's the house that McLean Quindon designed. The front facade wall is designed to marry to the old kitchen garden wall. And I should also say that our landscape designer was my wife. So she's done a lot of planning in that. And the other side of McLean Quindon is, as well as designing the externals, they design all the internals of the house. So that's the decoration, the interior joinery, lighting, kitchen, and all the fittings. And we've used a lot of natural materials in the house, including pure clay plaster, which is very nice to look at, but also a much more sustainable alternative to normal plaster and paint finishes. For the main construction, we used the four-wall advanced SIP system made very locally by Tightness, and it was further clad externally by 150 mil of insulation. Now, Tightness were formerly timber frame passive house builders, so as well as the SIPs panels, they did all the timber floors and the roof. And erection on the site was done, a manual process done by a team of 5 who basically constructed most of the house, including floors and roof. At the same time, all the windows, roof lights, and the final roof membrane were installed. So we went from bare slab to first fix in about 2 months. Looking at our energy system, we're 100% electrically powered because we have a private borehole and a private sewage plant on top of the usual domestic circuits, including the ASHP. So we just have one utility company to deal with for all our outgoing bills and our incoming feed-in funds. We also use thermal and electric batteries to optimize our solar power use, and we have an e-car on order. So after 2 years experience of anything performance has exceeded expectations, the headlines are that we're around 40% power positive, CO2 negative, and running cost negative. Unfortunately, we couldn't go for Passivhaus Plus because of our relatively large footprint, as we're mostly single story, as you saw. Now, as well as the outside, the landscape contributes to our ecological performance and carbon offsetting. We've done a lot of planting, including well over 100 trees and over 300 meters of hedges. And after many years, the kitchen garden's now supplying food again. The birch copse on the southwest is also intended to provide solar shading. Obviously, the more so, the more it grows. Summer overheating was noted as a potential risk by our certifier, but one that could be ameliorated by window and door opening. And in practice, we found that we can control it. We cut radiant heat by closing the big blind over our central roof light, and also the roller blinds and the Venetian blinds in the main living room and in the bedrooms. And then we get airflow going, usually by opening a relatively small roof light on the roof and a sliding terrace door, and possibly other doors and bedroom windows. There's a door on each access of the house, so we can usually get cross ventilation going quite easily. So almost all our overheating turns out to be when we're away, meaning that we can't open the doors and windows. So in winter, I think the subjective thing we notice most is that we're often surprised when we step outside and find that it's cold. And we can also do a direct comparison with our old house, which is a couple of 100 meters away, in that our heating year is now 4 months rather than 7 months. And we're using only, or generating only about 2.5% of the carbon dioxide that we used to generate. So overall, the benefits, both comfort and performance, we found have easily delivered on the Passivhaus promises. And one thing as we've found in personal behavior is that we've started modifying our behavior by watching the solar ray monitors, a bit like you modify your driving behavior when you watch the battery in and battery out on an electric car. So as was said, Passivhaus certification was a first for the architects and builders. So that in itself meant a lot of lessons were learnt. And we tell anyone who went down this path that getting it right, testing it with PHPP in the design stage is absolutely what you need to do. And as a result of doing that, we had no nasty surprises later on. We had a great team and everyone was on board with the Passivhaus goals and techniques. And also, since many of the main components like windows were Passivhaus certified, the subcontractors fitting them tended to bring Passivhaus know-how and experience to the project and pass it on to the less experienced teams. That was because there was good communication and a good relationship between all our teams. And the other thing we learned, of course, was that a critical component is the Passivhaus champion. And for us, this was our project manager, Russ Hancock, who became a convert from the start. He did the training, kept the book on his desk, trained the subcontractors, and where necessary, he checked everything and everyone every day. And personally, he even did a lot of the taping at the end of each day. Now, recently, Justin Beer made a good point in a REBA conference that beauty and performance are entirely compatible. And the REBA Awards are increasingly requiring the Passivhaus approach as they head to their 2030 challenge. And it's great for us that we're currently shortlisted for the awards. Of course, we're not the first in this respect, but we're still very much in the minority. And we believe we can help spread the word. And one of the ways we've done that is by getting into a lot of architectural journals. And I've given talks to local eco groups on Passivhaus. And also we've chosen Passivhaus in our project name to draw attention to the Passivhaus aspects of it, even though I can assure you it's not the name that's on our gate, although we have the plaque right near our gate. So for further information, McLean Quinlan have got a website, the builders, Gordon & Sons, have got a website, and we've got a website for the house, which has got more photographs on it than you could ever want to see. So thanks, back to you, Emma.
Thanks, Nigel. Fantastic project. I'm looking forward to coming to visit.
You're welcome.
So we've got a couple of questions that have come in through the Q&A. Just want to kick off with the first question. That's from Nick. He's asking whether or not you used any recycled materials as part of your project and where your timber was sourced from.
The timber was locally sourced. I'm going to be vague about this because I wasn't involved in we aimed where possible to use recycled materials, but it probably wasn't an upfront headline of our materials. So I had to be slightly vague on that since my builders aren't here to help me out.
Okay, thank you. We've got another question that's come in. Is the house connected to the national grid? And if so, what are the in-use emissions?
We're connected via Octopus to the electrical grid. So in doing the calculations we did for carbon dioxide generation, I went for the latest, I think it's 0.25 kilograms per kilowatt, if that answers the question. So we're actually dealing with the same company for feed in and feed out. So we found that using the batteries makes a lot more sense nowadays in sidestepping the energy provider, really, because the feed-in is so low and the energy never has to leave the house in that case.
Right. Another question from George. He comments that it's a great project and congratulates you. His question is, what's in the basement?
I'm in the basement. So it's the plant room and our attic, a storage room, but probably the bigger part of it is so-called media room, which is basically our private living room, which we find stays at an almost consistent temperature for the whole year. So we actually use it as the warmest place in the house in winter and the coolest place in the house in summer. So we spend quite a lot of time here, especially in the evenings.
Okay. And what made you choose SIPs over alternatives?
It was sort of a joint decision with the builders and the architects. We'd come across the company basically because we'd been on a Passivhaus Open Day visit to the first Passivhaus in Devon that happened to have been built by Tribus in their timber frame days. So we knew of them for both reasons, and that our builders were interested in it from the SIPs point of view. So we all went, the whole team went, including structural engineers, and everyone liked what they said and what they showed us. And we watched some of our panels being made by the same guys who then came and built the house. So that's probably the answer to why we went specifically for these high-tech SIPs panels.
Okay, and just a final question relating to the SIPs. Are you aware of any environmental concerns with regard to the foam insulation in the SIPs panels?
Sorry, what concerns?
Environmental concerns in terms of the foam insulation in your SIP.
Yeah, I know there's concerns to do with the inbuilt energy cost, as it were. I've talked to Tribus about it, and they they're very keen on the fact that it's cradle to cradle product, and that if it comes to it in however many years' time, 100 years' time, the polystyrene foam especially, and all other aspects of the panels can be recycled and reused.
Okay, and one really quick question, a bit of a cheeky one from Caroline, slides, but she's just querying what the per metre or per square foot build cost was.
Inexpensive, in the area of £4,000.
No comment. I would.
that goes with the territory of building a Para 55 house, I'm afraid.
And also, I think, you know, it's how you value your home, isn't it, Nigel? So evidently, you've produced a fabulous home, and often you can't put a value to that.
Yes, it's a house for life, and we also went for the you can't take it with you philosophy.
Thank you, Nigel. Thanks very much.
Pleasure.
That rounds up the finalists for the small projects category. So we had Larch Corner, the Timber Triumph, our New Forest Enefit, and our Retrofit Dream Home, as well as Devon Passivhaus, the contemporary sleek self-build. All of them are winners in themselves for being successfully shortlisted, but I'm afraid there's only one prize. So which is your favourite? Well, you have the chance to vote shortly, but let's just find out what the judging panel voted as the UK's 2021 Passivhaus Awards Small Projects winner. Now, before I announce the winner though, I need you all to get your video filters ready and the drum rolls ready, and to raise a glass to our 2020 UK Passivhaus Awards Small Project winner, which is Larch Corner.
Wonderful, thank you. Superb, thank you. Well, I've got for my daughter, I will duly appoint myself with a, yeah. Thank you very much. That's excellent news. Well,
congratulations, Mark. How are you going to celebrate?
I think I shall be drinking this bottle of champagne. Yeah, that's wonderful. Thank you very much for everybody that voted. Thank you very much for. It was really stiff competition. So that's yeah, very lucky on behalf of Mick and who's the client, of course, and Andy Mackay, who's the superb contractor. I'd like to say thank you.
Fabulous. Well, thank you, Mark, and congratulations to all the other participants for the small projects category. There is still a chance for you to win through People's Choice. So do stay with us, and by all means, canvass support via the chat function. We're now going to move on to our large projects category, and it gives me great pleasure to welcome Paul Smith of Greengage. They have very generously sponsored this year's Large Projects Award.
Hi everyone. Sorry about that. Hope everyone's enjoying themselves today in this event. So I'm here to represent Greengage today. And so on behalf of Greengage, we'd like to thank, first of all, the Trust for offering us the opportunity to sponsor the large projects category at today's event. And we'd also like to say how proud we are to be sponsoring the 3 projects put forward this evening. There's some great projects going on. We'd also like to take the opportunity to thank the wider Passivhaus community. We really enjoy and appreciate being involved with such a supportive, close-knit group of passionate people who all seem to be moving in the same direction. And it's great to be part of and witness the Passivhaus movement grow and develop, not only in the UK, but globally. And we look forward to remaining a part of this movement at this really critical point in the challenge to adapt to mitigate climate change. So thanks a lot, Emma, and pass back to you.
Thanks very much, and thank you, Greengage, for your ongoing support to the Passivhaus Trust. It's very much appreciated. Now, our first shortlisted contender for the Large Projects Award is Agar Grove in Camden. This is presented by Katie Clements-Jackson of Max Fordham, the project engineers. This is an exciting and ambitious project that promises to be the UK's largest residential passive house development once all the phases are completed. This is another local authority-led passive house development, one of many that we're seeing across the UK, delivering high quality homes that eradicate fuel poverty and enact local climate action pledges. Thanks, Katie, for joining us this afternoon. And don't forget, everyone, to post your questions for Katie in the Q&A function.
Before the development, the estate was a number of H-shaped blocks, and the homes were cold. They had lots of damp, very drafty windows, expensive to heat. We consulted with the community. Once we understood that residents wanted comprehensive redevelopment, this would be Camden's largest regeneration redevelopment scheme. And so there was a desire to do something extraordinary.
One of the things that's really struck me about this process is actually the comfort and the positive benefits that a passive house building can bring.
It would address the fuel poverty on the estate. It would mean that we invested in more passive measures, and we already had to do some of those things. So triple glazed windows because of the railway.
It's been absolutely great that we've been able to demonstrate it on this scale, and with the future master plan of nearly 500 units we're going to be at soon.
One of the really informative parameters for the master plan actually wasn't passive house. It was actually keeping the community together. So everyone stayed here. They watched their new home being built and then moved in. And what that meant was the master plan's quite granular. It's like a puzzle where we did it in quite small phases. The palette materials is deliberately simple. It's brick, concrete, banding, a little bit of muted colour. And when you look at the future phases, they sort of use the same DNA.
This generous balcony that goes across the whole width really helps the control of solar gain from the south. And that's just demonstrating how really good thought out solar shading can actually help.
You have to give kudos to Michelle really, because she is that golden thread through the project who knows every part of it.
Residents are happy with their new home. We're getting data back that shows us that the building is performing how it was designed.
Thanks for the introduction. And hello everyone, I'm really happy to be here today presenting Agar Grove Phase 1A at the Passivhaus Awards. As Emma introduced me, I'm Katie Clements-Jackson from Max Fordham, and we carried out the MEP and the passive house design on the scheme. So Phase 1A is indicated that by the orange box you can see on the master plan within the wider estate regeneration context. The project includes 38 socially rented homes in this block, and we achieved Passive House Classic certification in April 2018, and we've been monitoring the performance of the building ever since. The success of the project wouldn't have been possible without a massive deal of effort from a cast of thousands who I'm representing today, and from the amazing spirit of collaboration that we all shared on the project. Another key factor in success was the fact that the Passive House brief was championed and supported by Camden, our client, throughout the design process. The existing homes on the estate were undersized, as well as poorly laid out and disconnected from the wider context. The local residents voted for redevelopment, and the proposals double the density of homes on site, which leads to bigger, better, low energy and fit for purpose homes for the existing residents, subsidised by the market sale homes. This is a visualisation of what the regenerated Agar Grove estate will ultimately look like, and the site is bounded by 2 railway lines. Phase 1A is completed, 1B is about to be finished, and 1C has started on site. At the heart of the design philosophy was Camden's goal to tackle fuel poverty and to provide low carbon homes, improving the quality of life for the estate's residents. Another key design principle was simplicity, using an efficient form and good detailing to simplify other aspects of the design. and to reduce maintenance requirements and life cycle costs. The existing estate was home to a thriving community, and it was important to Camden to retain this. The master plan was developed around a single decant promise, so the residents would be able to stay on site and move straight into their new homes, which has led to a series of smaller development phases, with 1A as the first part of that. Hawkins, Brown and May worked together on the master plan to provide different but complementary visual identities around the site. The design creates community through a series of streets and squares, and with an awareness of the wider context of the surroundings. Block 1A has a north-south orientation, which is well suited to Passive House. Some of the other phases have different orientations, which will be more challenging. During the planning, we proposed that a Passive House development with communal heating would perform better in use than a non-Passive House development with district heating, even if they looked like similar in SAP models. Our research was enough to persuade the GLA and to obtain planning permission for one of the first large-scale residential Passive House buildings in the UK. And here is phase 1A's energy performance from PHPP. It was deliberately designed to come in a little under the classic targets to allow for the unexpected. The actual occupancy for the site in use ended up being larger than we expected in the model, with 105 people in reality compared to 81 from PHPP. Agar Grove's measured energy use achieves the REBA 2025 target, or it did until about a week ago when the target got reduced. The performance is lower than the UK average for Passive House buildings, based on research from the Building Performance Network. And in order to get to the 2030 target from REBA, we would require a low carbon heat source. Our in-use heat losses ended up being higher than we had modelled, and this was partly because the boiler flow temperature had to be increased slightly to improve the controls operation and the stability of the HRUs. The performance is good considering that it was designed before the Subsea Heat Networks Code of Practice was released, but there is room for improvement. We monitored the temperature and other parameters in a number of flats, in 3 sample flats, and the data demonstrates that the temperature never drops below 20 degrees in winter. The winter heating strategy also benefits from solar gains coming through the generous south-facing balcony windows that are shaded by the overhanging balconies in summer. A little more on the summer comfort strategy is that it was based on a few key principles. Firstly, minimizing internal heat gains, which was done through insulating a pipework effectively, creating a lean pipework design and minimizing lateral distribution pipes, and with low LTHW running temperatures. The glazing was strategically sized with the balconies blocking peak summer sun, and we had large openable windows for purge vent. The flats provide a comfortable, spacious living environments for the residents. And feedback collected by occupant surveys showed that people noticed a real improvement in air quality and that the residents love the spacious balconies and the secure rear garden. The northern facade has less glazing than conventional multi-residential projects, but it has insulated side panels which make the openings look more generous. The shared entrances have a view all the way through the building into the garden at the rear. And due to the narrow gauge of the block and the internal glazed screens, this allows views and ventilation through the whole building. The team went on a learning curve in order to learn how to deliver Passive House at scale, which had not been done at the time. Some of the challenges included adapting the PHPP modelling tool to model a whole block rather than an individual home, designing to maintain the air tightness line, working out how to air test a large building, and designing a thermally broken balcony structure. The facade appearance had already been presented to the public before the decision to go Passive House. Therefore, some of the details had to work harder in order to meet the Passive House standards. For example, the insulated side panels did not perform as well as a full wall build-up would have done. Setting a Passive House brief from the outset would ensure that details like this can be optimized from the get-go. Running communal LTHW systems, such as our boilers here, at lower temperatures pushed the then available technology to its limits. And you can see a range of temperatures in degrees C of a range of different systems on the slide. Heat pump systems with ambient loop distribution would be optimized to operate at these lower temperatures and are being used on Agar Grove Phase 1C. I'll wrap up by saying Agar Grove Phase 1A has collected various awards in its lifespan so far, and it has paved the way for future large-scale Passive House developments, proving the concept and contributing to overall upskilling of the industry. Thank you again to everyone who made it possible, and thank you for listening to this presentation.
Thanks, Katie. Okay, we've got plenty of questions that have come in for this project. So I'm going to kick off with questions with, firstly from George. George's got a question on whether or not you've had any feedback from residents on how the homes are performing now during warmer summers and potential heat waves.
Yes, so we have carried out a couple of occupant surveys. The whole design team collaborated on these and it was led by Camden. So we had questionnaires and we went around knocking on doors, asking people both qualitative and quantitative questions about their experiences, as well as the monitoring that we had. The summer that we did that was one of the hottest summers that we had on record. It would have been 2018. And we found that people had, in some cases, been experiencing quite high temperatures. And so it was part of working with the residents, because the passive houses are ways to keep them cool are perhaps different to what people might expect in older, leakier properties. So things like helping people understand that closing the blinds to block out the solar gain might be ways to keep it cool. But unfortunately, we haven't yet been able to analyze another round of data to see if that improved the next year. But yeah, I think it was mixed, and we're hoping that it will improve over time as people kind of figure out the best ways to keep their flats cool in summer.
Okay, thanks, Katie. We've got a question which probably applies to most of the projects that we've covered this afternoon, is relating to getting suitably qualified contractors for passive house work. Now, I know you had the Hill Group working on your project. What was your experience in terms of the ease in which to get contractors?
So I think I'm joined today in the Q&A by Seth from Hawkins Brown. I just want to introduce him and say thanks to him for joining. If you want to jump in on any of these questions, Seth, then please do. I would say I think if Seth's got any comment on the tender process, I'd appreciate that. But in terms of Hill's work on the project, they used it as an opportunity to upskill sort of during the construction of phase 1A, and we're already seeing real benefits on 1B from that learning that they incorporated. Would you add anything to that, Seth?
Yeah, I think the reality of it is, if we go back, when we did sort of tender information in 2014 to 15, it was probably quite difficult to find contractors to do a building of this size for passive house. And Camden and Arcadis sort of did the selection procedure. I mean, what I would say about Hill is they really took the task on and they really learnt about it. And yeah, we've learned a lot of lessons on this first phase, but Hill are still with Camden now building the third phase. So it's been a learning process. I think now, 5 years on, 6 years on almost, as we start the third phase, I'm starting to get queries from volume house builders about passive house. So I think to answer the question, is it difficult getting contractors? Yeah, 6 years ago, yes, and now much less so, I think. But I think Hill have, by taking this project on and really sort of tackling the passive house element of it, they've sort of put themselves out in front really and also, I think we should give kudos to Archetype, who were the sort of contractor side delivery architects, with us staying client side with Camden. They brought in the expertise as well, and Peter Warm Associates were transferred across to Hill as well. So, yeah, lessons learned, but they had the right team around them, I would say.
Thanks, Seth. And whilst we still got you, we've had a few questions on the balconies. So I was wondering if you could give us some insight in terms of how you designed or delivered the thermally broken balconies on this particular project.
So it's actually a separate steel structure. So steel's on the outside, and then there are steels that are the same depth as the brickwork within the brick outer leaf. So it's a balcony on the face of a smooth skinned sort of brick box, and we did a lot of work with Stantec, the engineers, on at one point the tender design was actually using a thermally broken balcony connector, which we know adds a sort of phi load or additional line, a thermal line across the building. And during the detailed design phase, in collaboration with Archetype, I think Hill were very keen to sort of really separate that out. So that again was part of this bringing together of this big team. It became a separate structure.
Thanks, Seth. And Katie, I don't know, are you involved in the tower block retrofit plans on site?
So we, at the design phase for the overall redevelopment, all of the buildings were designed to sort of tender level, but then they're being procured piece by piece. So I can say that on that block, it's going to be BREEAM refurbishment, and the plans are to retrofit it and keep it in place, unlike the plans for the rest of the block. But yeah, I think that there's still quite a bit to be developed on that before we can really say what the final outcome will be.
Yeah.
Okay, thanks, Katie. And another
to put in there. So
sorry.
For the tower block as well. I mean, it will be a deep retrofit right back to the concrete frame. So in many ways, there's nothing to stop it being a full Passivhaus certified building. But we've got 2 more phases to come in between. So there's a lot of detailed thinking to happen. Yeah, sorry.
Great, thank you, Seth. And just another final question, Katie. Is this, obviously it's a residential scheme and affordable homes. Are these for affordable rent or shared ownership? Do you know what the 10-year mix is and whether or not people have purchased any of these, and if so, for how much?
So in terms of the breakdown on the site, the majority of the homes are rehousing the Camden tenants. And then as part of the increased density, there are also private sale homes being introduced, the basis being that the income from those would fund the overall redevelopment and the increasing quality of the housing. I think there are 40 intermediate 10-year dwellings being introduced as part of the scheme, and they're part of the phase 1C, which is the next one that's just started on site. I believe the private sale homes in Block G, which is part of phase 1B, which is just about to be completed, have started selling, but I'm afraid I'm not sure of the how much they've gone for, unfortunately.
We have to get people to have a look on Rightmove. Final question really from Peter, and this is a great sort of Passivhaus myth question. It's about clothes drying and dedicated clothes drying space in future phases. Obviously with Passivhaus accommodation, I know the apartments that we've built, one of the luxuries of Passivhaus is that clothes can dry without the need for any tumble dryers and the like. What clothes drying provisions did you include within this particular development?
So I think this is a project in London, and I think one of the missed opportunities in legislation is having space for drying clothes. The London Housing Design Guide in 2010 was a great leap forward. And I think had it had laundry in there, that would have been great, because everyone has a clothes maiden with clothes on all the time, especially if you've got kids, especially if you've got children. So in the first phase, we'd have drying over the bath, and you can do it in the home. And also remember in winter months as well, when you want to sort of humidify the home, actually, a bit of moisture is perhaps not such a bad thing. In later phases, it's actually from the first phase is it has a south facade and a north facade, and it really sets itself up for deep balconies with solar shading. But because the master plan is based on a streets and squares approach, where actually we're stitching in with the context and forming the sort of building facades against roots, we've got east and west facades. So what we've discovered is actually that's quite difficult to manage in terms of the PHPP. And so we've actually internalized some of the amenity into sort of sunrooms to smooth out the thermal envelope, and they'd be perfect for drying clothes. So you can use it all year round. So I'm not sure I've answered the question, but the apartments are sized according to the London plan because we've got to build efficiently, but somehow Passivhaus is creating these additional spaces like internalized sunroom balconies, where actually they're a bit more flexible than a standard balcony, if that answers the question.
Thanks, Seth, and thanks, Katie. A great project to kick off our large projects category. Now, our second contender for the Large Projects Award is Cranmer Road. This is a cutting-edge student accommodation project at King's College, Cambridge. And this is one of a number of Passivhaus student accommodation projects that are popping up across the UK at the moment. And this is really encouraging to see. Willem Still of Max Fordham is presenting Cranmer Road this afternoon, and he's no stranger to Passivhaus, as he not only the consultant for this project, but he was also involved with Agar Grove to talk about hedging your bets, Willem. So thanks, Willem, and don't forget everyone to put your questions ready for him in the Q&A.
We couldn't accommodate many of our graduate students, but we also don't have a great deal of land to develop on. This, what effectively were 3 large gardens, lent themselves to developing.
We're in the West Cambridge Conservation Area, an area which is very prized and very heavily protected by the local planning authority. So we had to work very carefully, creating buildings that wouldn't harm but would improve the conservation area over time.
But what the students wanted to achieve was a low carbon output, and their target really was to not have any gas in the building at all.
Kings are used to owning buildings and maintaining them for decades and hundreds of years. We were looking at what's the best value for the college over the kind of timescales that they're used to thinking of, and so Passivhaus became one of the options for that discussion.
If you remember, we went to Norwich, looked at the enterprise building, and I remember the minute I walked into the building I was sold. I said, yes, this is going to work for our students.
And I think the challenge from the project's perspective was marrying that environmental performance with an architecture that is permissible in this part of Cambridge.
There's 2 kind of architectural responses and skins over the building, but the skeleton of both of them is the same timber-based CLT construction, so that's worked really well in terms of limiting the embodied carbon of the scheme, and also was a great way of getting the air tightness that we needed to achieve Passivhaus.
2 lovely old buildings is now 4 amazing buildings that will accommodate 45% of our graduate community.
We saw the difference when comparing it to houses where we were living in before. The room is soundproofed, the temperature is always under control. It was a nice space to live in.
A number of other colleges are now looking at going in this direction, and I think it's important that we do for the future.
Everybody, here we go back on. Great, thank you very much. Hi everyone, I'll be talking about Cranmer Road, which consists of 2 new build graduate accommodation buildings for King's College in Cambridge and some associated landscape works. The buildings were occupied in late 2019, so just in time to get nicely bedded in before a global pandemic hit. The genesis of the project was King's need to accommodate their growing student population. So before the project, they could house only about 50% of their graduate students. There's limited real estate within Cambridge, so developing on land the college owned was attractive, and there was also an opportunity there to help develop the student community on the site. As part of developing the brief, the college consulted with their students, and this brought out a couple of key factors. So the students were really interested in the environmental impact of their buildings, and some students would prefer to pay lower rent for accommodation with shared toilets and showers rather than having en suites. The environmental aspirations helped to drive the choice of Passivhaus. The 2 buildings have got different characters. So the villa building pictured here faces onto Cranmer Road, and it's designed to sit within the arts and crafts context of the other buildings along this road. It's got 19 bedrooms over 3 floors with a kitchen on each floor, and it's a shared house with shared bathrooms. The ground floor kitchen is larger and opens out directly onto the landscape. The Stephen Taylor building is larger at 40 student bedrooms, and they're grouped around 4 kitchens. All of the bedrooms have en suites, 4 of them are wheelchair accessible. It also contains a common room which is available for students across the entire site. It's a mixture of brick and precast concrete facades as a response to the modernist architecture of West Cambridge. Here you can see some of the interiors. So the top 2 images of the kitchens in the Stephen Taylor building where the CLT is exposed. The bottom left shows a key feature for any student accommodation, live string music in the corridors. And the bottom right-hand image shows why it's difficult to predict small power consumption accurately for student accommodation. The scheme extends beyond the buildings with landscaping works which tie the whole site together. There's raised beds shown top left, which the students can use to grow their own food, and then a central wall which divides a wildflower element shown on the bottom left from a more formal lawn shown on the right, being enjoyed by the students on the day we filmed the video. As a client, Kings are used to being custodians of buildings for a long time, and from that point of view, it made sense to follow an all-electric approach to align with the ongoing decarbonisation of the electricity grid in the UK. Passivhaus helped to make this possible from a building regulations compliance perspective. The primary structure for both buildings is CLT. As mentioned in the video, although they have different external appearances, both buildings have a common skeleton beneath the surface. CLT worked well from several perspectives, limiting embodied carbon, providing a solution that was quick to erect on site, and helping to contribute towards the airtightness of the buildings. The energy strategy of the buildings was designed to be as simple as possible, so efficient and to minimise distribution losses. Domestic hot water is produced by instantaneous point-of-use water heaters with wastewater heat recovery and low-flow sanitary ware. Space heating is by electric panel rads with local control. So, how's it worked out in practice? The CLT is primary air tightness line was successful, and combined with the taping and EPDM for the windows and a few other services penetrations, we got the final air tightness results shown here, so 3 to 4 times better than the Passivhaus limits. And obviously Passivhaus being much better than building regs in general in the UK. We measured the day with the highest heating load, which is shown on the graph here. So the outside air temperature shown in the horizontal lines for the orange, and that was in between the 2 days that PHPP uses as a test. The average heating load, so the green horizontal line, was just under 8 watts a square metre. So we're happy with that compared to the Passivhaus targets. Although the peak heating load was low, the heating demand figures have been a bit higher than predicted. And we think this is largely due to students wanting their rooms hotter than 20 and learning how to override the temperature controls on the radiators to achieve this. We're using a modified system in subsequent projects to give students some control, but reverting back to a reasonable base temperature after a few hours. Another lesson learned has been around student showering. So PHPP is based on 5 minutes per shower, 0.7 showers a day. Energy saving trust figures suggest it's about, in the UK, it's about 7.5 minutes a shower and 0.8 showers a day. And feedback from students shows plenty of them take more than 20 minutes because that's when the lighting controls plunge them into darkness. Measuring the annual energy usage of the buildings was complicated a bit by a global pandemic. So this is what we've got so far. Industry benchmarks are in grey at the top, reference projects just below those in blue, climate emergency targets including Letty and Reba in orange, and then the green bar at the bottom is Cranmer Road. So generally good. And the student feedback overall has been positive. So the graph shown here is from a bus methodology survey, which asked all occupants in both academic years to give feedback on the buildings. This is a response on overall comfort, which is encouraging, and the quotes saying the building is modern and comfortable is from one of the students. As you'll have heard from the video, the feedback from the college has been positive. They're developing buildings elsewhere in Cambridge, including another project with accommodation for 60 graduates and 24 apartments for fellows. Following the Cranmer experience, this project is also pursuing Passivhaus and incorporating a lot of the lessons learned from Cranmer. One of the things we've liked beyond the buildings and the landscape themselves of the project is the legacy that it's generated. So all of the original design team are now working on other passive house projects, sometimes together and sometimes apart. This is one of the earliest passive house projects for us at MF, and it's the first for both the architect and the structural engineer as well. And it also seems to have contributed to a spread in passive house within the University of Cambridge. Obviously, we're not claiming sole credit for this. There's a national increase in passive house, which is brilliant. But given all the discussion around exponential growth and pandemics in the last year, it's nice to see something where an R value of more than 1 is a good thing and to be welcomed. So thanks for your time. I'd just like to finish off by crediting some of the key organisations involved in the project. So obviously King's College as the clients, Allies and Morrison's architects, Smith & Morwick structural engineer, Faithful of Gould as QS and project manager, RG Carter as the main contractor, and of course Warm as the passive house certifiers. Thank you.
Thanks, Gwilym. Another cracking project. So we've got some interesting questions in the Q&A. So
it's always ominous. Good.
I'll start with the hardest first, shall I? The first question is from Scott Crease. Know where your sideburns have gone?
It's a seasonally adaptive comfort, Scott. I got excited at 3 days of sunshine and cut them all off.
The second question is from George. Thanks, George. He congratulates you on this sensitively designed scheme. What George wants to know is, what are those chimneys on the more traditional looking building?
They're not a technically performing thing, if that's what you're asking, George. I think they were there to deal with some of the challenges we had around getting planning and trying to sit in with the arts and crafts kind of vernacular or style locally. So yes, they're there for ornament rather than technical performance.
It's a bit like your sideburns.
Yeah, there wasn't much function to them.
We did have a question from Mick in the chat actually, and he was asking about the air tightness of the CLT and your kind of air tightness strategy. Can you perhaps give us a little bit more insight into that, please?
Fine. So the CLT panels themselves were the main air tightness components, and so we had a 5-ply CLT that was specified by Smith & Morwick, and then we had tape to join the panels to each other. The windows were fixed back to the CLT using an EPDM, and then we had some proprietary taping and grommets for the services penetrations, etc. So the CLT formed the primary air tightness line, and then we were connecting everything else onto it. The breather membrane was there more for protection of the CLT than as anything to do with the air tightness.
Okay, thank you. And then we've got another question from Jay Cottrell. Given that your client is an academic establishment, did you calculate or get any feel of the embodied carbon for this particular project?
The short answer is no, I'm afraid. We have been, I think, the structural engineers have done some calcs, and I think the architects have done a few after the completion of the project, but we didn't have it as a design target when we did the original design.
Okay, I anticipate that going forward in the future, that's going to be a regular question, isn't it? So
yes,
that's certainly showing us how things are changing. Thank you, Gwilym, and best of luck.
Thank you.
Well, our last finalist for the Large Projects Award this afternoon is Seton Beach. This is a Passive House Plus project. It's an amazing apartment development right on the seafront of Seton. Mike Webb, the MD and founder of Seton Beach Developments, is presenting this project to us this afternoon, giving us a good insight from the developer's perspective. Now, Mike is a Passive House certified consultant, and he is a passionate and a new convert to the Passive House standard. So don't forget, keep raising your questions for Mike in the Q&A, and we look forward to looking at Seton Beach Passive House Plus.
Hi, my name is Mike Webb. We are the developers of Seton Beach, the first Passive House Plus multi-block in the UK, and we had the opportunity of working with Thomas Gartner to develop something really iconic on the beach.
And what a beautiful day. Something quite unusual on this project is here that it didn't need Passivhaus. You didn't need it for planning. You probably didn't need it necessarily for selling these flats because of the location. It was actually your ambition to increase quality.
We had the opportunity of meeting Emma Osmondston about 10 years ago now, and she spoke with so much passion about building better and the fuel poverty and various things like that that it mitigated. And I just thought, well, if we're going to develop something like this is a one-in-a-lifetime opportunity to really do a wow project.
The whole design idea from the original designers, before this was a Passivhaus actually, that they wanted this design of an ocean liner stranded on the beach. And so that's what we were very keen to maintain when we developed the Passivhaus design, and the detailed design of course as well, to maintain this feel of an ocean liner, but also the elements of a sea, scales, materials that we find in there, the smoothness, the curves, don't compromise on any of these elements in there, keep this organic feel to it.
Classic Builders Southwest done a really good job for us in the way they managed the scheme, right from the piling and then just seeing the whole thing rising up.
And in terms of buildability, it was a challenging site. It's a very tight site. We're building right up to the edges as well, of course. We're using mineral materials like polythene, clay blocks as insulants in here with a timber frame construction and cellulose fibre in the upper floors, with the whole principle of trying to avoid plastics wherever we can.
Whilst we could have made more money here, we didn't. We sacrificed a little bit of margin for the environment, but I think it's the right thing to do. And it's a shame that more developers don't embrace our thoughts and just stop talking about it. There's a lot of greenwash out there, and just do it. Our journey began in 2015 when we saw an old house whilst walking along the seafront with some friends in Seton. I spotted the development potential, and having best guessed some costs and margins, I phoned a close friend and asked to borrow £3 million. After 3 days of anxious waiting, he said yes. Seton Beach began, and with the support of my long-suffering wife Audrey, we cracked on. Seton is a seaside town on the south coast of Devon between Sidmouth and Lyme Regis. Despite being on the Jurassic coast, house prices in Seton were low in 2015 and did not support iconic architecture. We took the gamble anyway and just did it. Within a week, we had secured the site, and Clifton Emery architects in Exeter were appointed and gained the planning consent after a long battle with East Devon District Council. The old house was very inefficient in both its land usage and its energy consumption, as demonstrated by the EPC. We then realised we had a Marmite scheme on our hands. People would either love it or hate us for knocking down the old house, which happened in April 2017. I made the decision to build to Passivhaus standards, thanks to Emma Osmondston, who I first met back in 2014 at a CPD in Coventry. That motivated my decision. We then appointed Thomas Gartner from Gallen Snowden Architects, and he just simplified the process and encouraged me to retrain as a certified Passivhaus consultant. Our scheme provides 8 homes on the same land footprint and cut the energy consumption by 91% compared with the old house based on EPC data. Classic Builders commenced on site in March 2018, then managed this tight site with precision, delivering us an excellent building. We arranged a Passivhaus contractors training day with Warm in Plymouth for Classic Builders and their subcontractors. Collaboration and education underpins the success of our project. All insulation arriving on site was evidenced by our meticulous site manager, Robin Pike, who Classic employed to deliver the project. He became the air tightness champion, taking personal pride with a can-do attitude. We also engaged with the local community to keep them all informed and hosted 3 Passivhaus open days to educate the people on the 30-year-old build standard we were achieving. Once the first floor shuttering was removed, curvaceous balcony was released, and we realised the plans drawn by Thomas had finally come alive. That said, curves cost, and the time this detail took to replicate on the next 3 floors was really underestimated. It's the hidden details that add to the building's performance that increase the cost. For example, the Shirk thermal brakes. Superior German engineering does not come cheap. I was convinced that Thomas was just helping the German economy. The subservient penthouse had to be a lightweight timber frame insulated with warm cell. The heavyweight main structure adds thermal mass to assist the building in maintaining constant temperature between seasons. This also helps with the overheating. as do the large south-facing balconies. Overheating in the penthouse was mitigated with external roller shutters on the large south and west fenestrations. Cross ventilation also assists, and this was evidenced last summer. 30 degrees on the beach and a comfortable 24 degrees in the penthouse. The mechanical and electrical specification we did ourselves with assistance from our subcontractors. Total Home Environment supplied and designed the MVHR, and Forwards of Sidmouth installed it, along with all the electrics, plumbing, kitchens, bathrooms and tiling. The MVHR combi provides 50% of the heat demand, with the balance made up from electric towel rails. We are gas free. This prompted the decision to install solar panels that, with the low energy demand, became the first certified multi-block in the UK to achieve Passivhaus Plus status. To achieve this, we had to get 49 solar panels on a limited roof area. And as the system designer myself, I found this one of the most challenging schemes I've put together, especially with the roof windows that help provide every single room on the top floor with natural light and also roof access for maintenance. We then decided a fixed handrail would be required to meet our CDM obligations, thus ensuring safe maintenance. There's even a tap on the roof to clean the solar panels. The incoming electric is communal, so that any self-generated power can be used by other apartments and also electric car charging in the parking bays. This minimises our export back to the grid, because the more we can use, the better we are for it. All apartments have half-hourly import-export meters that are on our own cloud-based platform, so data is readily available. And this shows that generally we are on target for forecast versus actual consumption. Amazing west views from the penthouse, as you can see, straight across the beach. Due to CODIV, this was the last apartment to sell in February 2021. The exterior is clad with zinc shingles that offer a 30-year marine grade warranty. We recycled the timber from the old house to build a pergola. We also rebuilt the front wall from the stone we saved from the demolished house. Very sustainable to help offset the embedded carbon in the construction phase, but also exceptionally hard work. We even had some celebrity visitors arriving on their own eco-transport for unexpected site tours. And as you can see, that's where my picture today comes from. Certify your build and buy a plaque. If you built a Rolls Royce, you would not want to leave the badge off. We thank all of our team and our neighbours with a beach party in September 2019 that, due to the weather, was almost rained off. Fortunately, the unsold apartments became the new venue that day, and as most still had flooring to be specified by the end buyers, there was no damage done. All 8 apartments are now sold. My investor has all his money back with interest and a profit share. And may I take this opportunity to thank everybody involved with this project for an outstanding job. Our next project at present is a barn conversion where we hope to prove 100-year-old animal housing can be 2050 ready for humans. We do like a challenge at Seton Beach. And I want to close by saying my motivation is to get more developers to stop talking about it and just do it. Also, thanks to Norscombe Windows for their windows and also most of the images today. Thank you.
Thanks, Mike. Great to have you as a developer advocating so passionately for Passivhaus. So fantastic project.
Thank you.
We've got some questions coming in. First question that we've got is, what was the total cost of the project and the GDV? I don't know if you want to share all of that with us, but maybe a headline.
I'm more than happy. Most people that know me, I'm a very open book when it comes to my numbers. The GDV topped out at just under 4.8 million. The total cost, excluding the land, well, it was about £3,000 a square metre. So not as expensive as the other Devon contender today, but we had a lot of detailing with like mosaics that don't come cheap on the front. The curved balconies was a huge overrun on cost with those. We came to a very amicable agreement with Classic Builders who supported us through this scheme. The windows were a very, very big ticket item because there's so much glazing there. But in terms of the overall margin, I just about kept the shirt on my back because the COVID cost us extra interest on the timeline. And of course, when we started this project in 2015, Brexit wasn't a word, COVID wasn't a word, and there was also 3 general elections. So we've had a bit of a turbulent ride, let's say.
Right. We've got a question in terms of external space and landscaping. I know it was a very tight site, Mike. You've given us a bit of insight in terms of the car parking and the pergola. Was there any chance for any other external space?
Yeah, at the front of the development, there's a small walled garden that gives the ground floor apartment a bit of privacy from people walking by on the pavement. But of course, we've set them up about 300 mil from the street level anyway, because this was actually built in a flood risk zone according to the Environment Agency. But our finished floor level is actually 1.2 metres higher than 400 odd Bovis houses being built in Seton at the moment. So if we have a flood problem, they've certainly got a problem. In terms of the rear, the site actually slopes down slowly. And so we managed to get a parking space for each of the apartments. The penthouse also has its own garage. There's 2 visitors parking spaces, and all of this is in a secured by design gold standard parking lot. The whole building secured by design gold standard. And also the parking space is most big enough for lifetime homes compliant as well. So we've achieved those 2 standards. And of course, we've had Tom Gartner's input on building biology too. So we've designed out EMF zones and things like that. But the other thing that's in the communal area, we've also got a walk-in shower, toilet and washroom, so that if you've been to the beach and you've got a muddy dog or a wetsuit on, you can just shower off before you venture into your apartment. And it gives tradespeople on site somewhere to use as well.
Great, Mike, you've thought of everything. Just a couple of other questions. Did you consider the use of batteries, given all that solar PV you've got?
Don't get me started. So here we go. Having been at the coalface, we was MCS installers since 2010. And I will be brutally blunt and say I wouldn't put a battery in my home, and I've got 14 kilowatts of solar PV at the moment, because they are cost negative in terms of an investment decision. However, when vehicle to grid comes, which was the way you get the electricity out of your electric car, that's where the smart money will be invested in. So that's my word from an installer of solar panels since, and we've done over 250 schemes. I can show anybody a mathematical model on this if they want to challenge me on it.
Okay, thanks, Mike. And just a final question. Obviously, curves cost. You've got a lot of concrete in that building. Have you done any embodied carbon calculations yet?
I only learnt about this halfway through the journey, and I've got to be brutally frank that we know that we are a bit of a concrete monster because there's a lot of carbon in the concrete. We've offset that with the clay blocks, although they did come all the way from Austria, but that was Tom Gartner's specification. The clay blocks work very well, actually, to be honest with you. We've tried to offset the carbon, obviously, with our renewable strategy. We've obviously got no gas in the building at all either. But in terms of carbon calculation, if we did it again, I think we'd probably rethink how we would do it.
Okay, and then the last question just come in from Priyanka, thank you. Is there any communal space for residents to gather socially, or would that be on the beach?
It certainly would be on the beach, but we've got a very, very nice vestibule where there's actually a mosaic sort of wave that runs up through the building, and then there's a big mirror that replicates the sun. So it's very open plan, but there's no heating in any of our communal areas at all. And as soon as you step in, because the lobby is triple glazed and it's south facing, it feels warm all year round. It really works superbly well. But no, our mix of owners here, we've got 50% full-time owners and 50% are second homeowners. And they all seem to get on really well. And we've got our second owners AGM coming up in October, where I will declare the full year's actual versus forecast energy consumptions, because we manage the amount of water by sub-metering it. We, in terms of how much we know that is being brought into the building. We also do the same with the electric. And the electric strategy was quite unique, because if, let's say, one of the apartments is unoccupied because of COVID or because of the fact it's a second home, the power that that plant produces can be used by all the other apartments in the block. So we don't lose it to the grid, which is quite an unusual way of wiring it, but it took us a bit of a strategy to work that one out ourselves.
Well, thank you, Mike, and another fantastic Passivhaus project. Congratulations for being shortlisted.
Thank you, Emma.
Well, there you have it, 3 cracking Passivhaus projects in the large projects category. Congratulations to all of you for being shortlisted. I do not envy those people that have needed to make the decision, deciding between an ambitious council housing regeneration at Grove, the sustainable student accommodation at Cranmer Road, or the Passivhaus Plus apartments by the sea. But a decision has been made. And before I announce who this is, can I just remind everyone that we will be concluding the online voting for the People's Choice in a few moments. So don't stray away and get your fingers posed ready. Meanwhile, I'm delighted to confirm that the winners of the UK Passivhaus Awards 2021 Large Projects category is, get your video filters ready and the drum rolls going, and raise a glass to Grove. Congratulations.
Thank you so much. I'm really happy to accept a certificate on behalf of the whole Grove team, and I think I can't go without saying once more that the success of this project is due to the hard work of everybody on the team, and a massive thank you to them and for the vision that came from Camden of Passivhaus homes that would tackle fuel poverty. So thank you so much.
Congratulations, Beth. Congratulations for the team behind this fantastic project, and many congratulations.
Thank you.
Okay, so well done to all our shortlisted finalists today. We do have one remaining award, and you may argue that it's one that you all came for, the People's Choice Award. Can I ask all finalists to share their cameras, as we are now going to go live to the voting poll. If you've not done so already, may I ask that you get your fingers ready to cast your vote. But before you do, I'm just going to give you all a quick summary of our projects. We have a Larch Corner, our small projects winner, a timber lover's paradise that is nestled in the heart of Warwickshire countryside. This detached house matches Passivhaus levels, efficiency and low carbon materials, together with an air source heat pump and PV array. We then, of course, had our New Forest Enefit project, the retrofit of the 1930s cavity-filled home, providing a wonderful energy efficient renovated property in a fabulous coastal location, providing optimum comfort. We then have Devon Passivhaus, that elegant contemporary Passivhaus project that adopts a simple form and a wonderful palette of tactile materials to breathe new life into an historic walled garden. In terms of our larger projects, of course, we have our large projects winner, Agar Grove, the redevelopment of housing in Camden, providing fuel poverty eradication, occupant wellbeing, and climate active action pledges for the local authority. In terms of our other projects, of course, don't forget we've got Cranmer Road, the fabulous Passivhaus student accommodation in Cambridge at King's College, and last but not least, the Seton Beach Passivhaus project, that very distinctive, curvaceous 8-apartment development on the seafront of Seton. So, have your fingers on the ready, and we are going to give you a 30-second countdown to place your votes. And while our votes are being checked, verified and counted, can I just remind you all that we have an after ceremony party which can be accessed via the link that we'll put in the chat later. And whilst we're waiting for the results to be published, may I just take the opportunity of thanking all our participants for joining us today, the organisers and our generous sponsors, Greengage and Ecology Building Society, to Charlie Luxton for bringing some sizzle to sustainability, and last but not least, to all of you who have joined us this afternoon. And so I need to get you all drum rolls ready. I want to see as many additions to your screens. And the winner for the People's Choice Award 2021 is, and I'm told it's a very, very close thing, Cranmer Road. Congratulations, Cranmer Road. Willem, over to you.
Magic. Thank you very much. I'm delighted, and I'd say congratulations to obviously Kings as a client and all the rest of the team, including Carter's, Allies, Morrison, Smith & Warwick and so on, for delivering it. So many more of these sorts of projects in Cambridge and across the UK. Cheers.
Thanks, Willem. And congratulations to you and all the project teams involved with that fabulous project. Commiserations to our other shortlisted finalists. You're all winners, really. And many congratulations for your achievements in joining us here this afternoon. So if this afternoon's inspired you in terms of the projects that have been on show, then please do get in touch and get involved with the Passivhaus Trust. We have an icebox challenge in the run-up to COP26, which has been designed as part of an undergraduate competition. This will be at St Enoch Square in Glasgow from the 23rd of July to the 8th of August. We continue to run our series of net zero tutorials, so do drop in and learn from the experts on that in our Getting to Net Zero programme. And of course, we have our regular Passivhaus Trust newsletters, keeping you up to date with all the latest Passivhaus news in the UK. So all that's left for me to say is thank you for joining us this afternoon. Thank you in particular to Ben Adam Smith for the videos he's kindly prepared for today's presentations and for his ongoing support and help to the Passivhaus movement in the UK. I hope you've enjoyed your afternoon. Have a good evening, and I look forward to seeing you in the after awards party.